Another thing that happens as we increase our sample size is that the distribution of the mean of our sample changes. Imagine we rolled a single dice 200 times and plotted our results on a histogram. The results would look something like this, with a flat distribution. Now let's roll 2 dice, take the mean, and plot that into our histogram. After 200 rolls, the result looks like this. Let's do this one more time, only let's roll 6 dice and take the average. As we increase the size of our sample, the distribution of those samples begins to reflect the normal distribution. And this isn't just true with dice rolls, test scores, income, marathon times. No matter the distribution of a variable in the population, the means of samples of that variable will be roughly normally distributed. This is known as the central limit theorem. The central limit theorem states that the distribution of sample means approaches the normal distribution as the sample size gets larger, regardless of the shape of the population distribution. This is a beautiful thing. With a large enough sample size, our sampling distribution will be well modeled by the normal distribution. This allows us to apply certain statistical tools, such as the empirical rule, on our samples for any population. Another aspect of the central limit theorem is that as our sample size grows in size, its spread decreases. This makes sense if you consider the law of large numbers. As the size of our samples increase, their mean tends towards the mean of the population.